Okay, let's start talking about reactions of triacylglycerols. Those are the fats, not the fatty acids, but the fats. Quick review, we've seen that the way that you build a fat molecule is take a glycerol molecule, take 3 fatty acid molecules, and combine them. That's condensation. Combine them by boxing out water. That's condensation. So we've said that's condensation. And what you get is the triacylglycerol molecule plus 3 waters. Triacylglycerol molecule with 3 new ester bonds. This is the fat. It's the fat. These are the fatty acid building blocks that you used. You know that condensation and hydrolysis are opposite of each other. When you combine the building blocks to get the fat, combining is condensation. So fatty acids, what do? They do condensation. They're not doing hydrolysis. We don't break those up anymore. They're building blocks. The fat, the triacylglycerol, it is the big one. Notice it does not do condensation. It doesn't get even bigger. All it can do is go back to being small, hydrolysis. So the triacylglycerol, we can break those ester bonds, do hydrolysis by breaking it up. What do we get? Back to the building blocks, glycerol and 3 fatty acids. So that's the overview. You have this handout. Let's do an example though ourselves to make sure that we get it. So I'm going to look at this right here. Right here. I'm going to zoom in a little bit. This example right here. This is a triacylglycerol. You should be able to see that that's not a fatty acid, it's a fat, triacylglycerol. What's the ester bond? What is the bond that will break? It's the ester bond right here. That was the new bond that was formed when we built it from its building blocks, when we did condensation. And so that's the bond that'll break. That bond breaks. 3 ester bonds break. How do we know that this is even hydrolysis? Right here. H plus is the catalyst. Water, which was a product of condensation, is a reactant for hydrolysis. Now, at some point you might wonder, wait a minute, I thought adding water was hydration. Hydration is when you are adding water to a carbon-carbon double bond. We're not doing that. We're taking something big, we're going to chop it up and make it smaller. That's hydration. Water is a reactant for hydration. We will not see hydration at all. No hydration with carbohydrates, no hydration with lipids, and no hydration with proteins. We're not seeing that right now. So this is hydrolysis. We know it's hydrolysis. What will happen? We get back to the building blocks. That ester bond breaks, so let's see what will happen. Nothing on either side changes. The carbon skeleton doesn't change. I used to have 3 carbons, I still do. I used to have 2 H's, I still do. 1 H there, I still do. This stays the same, but now I need to turn it back into the alcohol. I'm going to write that H in red because I want you to see the water we added. Here's the H part of the water we added. Where's the OH part of the water we added? Well, let's draw in the, zoom out a little bit. Let's draw in this stuff, carbon double bond O and so on. So carbon double bond O, I'm drawing the pieces that I would get if I break that ester bond. Like that. And one more. I broke the ester bond. There it is. It's broken. You can't have carbon having only 3 bonds. 1, 2, 3. You can't have a 4th bond just pointing out into air with nothing attached. What will attach there? The rest of the water molecule. Water is an H and an OH. H, OH, H, OH. And of course I put the O attached to carbon. Oxygen makes 2 bonds. Hydrogen does not make 2 bonds. So I cannot put hydrogen in the middle. It's on the end. HOH, that's water. There's my 3 waters right there. So my products are what I knew they would be. Glycerol plus 3 fatty acids. I pulled that molecule apart. I cut it apart. I chopped it up. I used scissors. However you want to think about it, I took a bigger molecule. I broke it apart into more than one small molecule. In this case, glycerol and 3 fatty acids. You'll always get glycerol and 3 fatty acids when you break apart a triacylglycerol. Always. And this is how it looks. So can this be hydrolyzed? Yes. It's big. We can chop it up. Can a fatty acid do hydrolysis? Can it be hydrolyzed? No. This is a building block, so it cannot do hydrolysis. In our next video, we will see whether or not triacylglycerols can do hydrogenation. Hydrolysis, yes, they can do. Here it is. What happens if we try to do hydrogenation? That's next.